Greetings and welcome. We're going over the homework here, friends. We were talking about functions, and we put the fun... No, I'm not even going to finish that. Determine whether a relation is a function. Explain. So a relation was just any relationship between pairs of numbers. And we had a bunch of different ways of representing those graphically, through ordered pairs, through this little diagram, mapping diagram, through tables. And Cameron, there was a very special type of relation called functions. And functions have exactly one output for every input. So for problem 4, since my friends in real life, we are pressed for time with a half day, I'm going to jump right in and just answer this. Notice for problem 4, the input of 3, the x coordinate, has 2 different y coordinates. That's a problem for us, so this is not a function. Because if I say 3, you say, and then you'd be like, I don't know. Like, I've got 2 choices here. We wouldn't all be in agreement about what I say, right? And functions have one output for every input. Okay, how about 6 here? Oh, question, comment, observation. Huh, that is bizarre. Maybe so. All right, that's fine. Don't worry about it. We'll keep cruising. So let's see. Question 6. Here's my inputs. Is this a problem? Is it a problem that I've got inputs pointing to the same output? No, we're fine if outputs repeat. We're just not cool with inputs repeating. So this is actually, it's good. This is a function. Because notice there's exactly one arrow leaving each input. All right, and that's what would matter to me. There's one arrow leaving each input. All right, and how about for 8? If I say -3, everyone would agree 11 is the output. If I say 6, everyone would agree -7 is the output. Notice there's exactly one output for every input. None of these inputs are repeated, so this is a function. Question? Well, maybe it gets opposited in the process. Or maybe it's like -3 plus, I was going to say 8, but that's not right. It'd have to be like -3 plus 14. Eventually we will have patterns. Okay? There's no guarantee about what type of pattern this is. Today we'll see a particular type of function that has a linear pattern. But yeah, I don't know. Maybe you could figure out if this has a pattern or not. It looks like this is at least getting smaller as we go along. So there's probably a pattern that we could find, but they didn't say that it had to be. Okay, determine whether the graph represents a function. Now, my x's, right, my inputs are the horizontal, right? Inputs are the horizontal values, and my outputs are this y-axis. Notice that sometimes you can have a coordinate plane, your 2 number lines that are now like perpendicular and together, Cameron, with one another. And you could have kind of them intersect in the middle of the graph, but you could also just kind of be paying attention to just one of what these are called quadrants. So this is the upper right quadrant, often referred to as quadrant 1. Notice that this graph, we don't see the other quadrants over here, but you could imagine that negative numbers exist over here and here. But anyways, that's just side conversation. So the question is, does any input give me multiple outputs? Does any of the points on the x-axis have multiple points above it? And that does appear to be the case. It looks like 0 hits 2, bam, bam. That is not a function. 2 hits 2 points. Man, that's a sad line. Bam, not a function, not a function. And this is not a function all over the place. Excellent, excellent. And we're actually okay if there are values that never hit a point. We're okay with that. And it's still not a function, say, if it hit 3 points in a line or 4 points. Basically, a function has exactly one output for every input. There's only going to be 1 point above any x input. And this is called the vertical line test. Notice this squiggly over here, right? Maybe this scared you a little bit. This is a sinusoidal function. by the looks of it. In pre-calculus someday, you guys will see this. And even though it's a funny-looking curve that goes back and forth, notice that every vertical line I draw will only ever hit 1 point. So this is a function. That's a crazy one. Well, can I ever draw a vertical line that hits more than 1 point? No. So it's a function. It's not a linear function, which is what we're talking about today. But it is a type of function. And if you want to look that up, actually Waddy Math does have some videos about this, sinusoidal functions. And this is, by the way, a relationship that describes like the phases of the moon or the tides of the ocean. You could even have a general pattern almost to describe seasonal hours of sunlight or temperatures throughout the day. And a lot of things kind of have this periodic back and forth motion within our world that sometimes we'll use sinusoidal functions to describe. So let's see. Okay, here's the interesting stuff. Domain and range. So domain was the set of all possible inputs, right? What are the possible inputs? And so the way I like to think about it was, what if I was to smoosh this graph all down to the x-axis, right? What points would remain? And so the domain is a set. This is called set notation. The way of writing a set is with these curly braces. And the points that happen are -2 would be one of those x values. Looks like, yeah, thank you. Excellent. Right? And this is, I think we did we call this discrete and continuous? Did we get to that yesterday? I don't remember. If not, we're going to hit that today or tomorrow. This only has 5 points. It has a non-infinite amount of inputs, and so this is called discrete. It makes jumps in the graph. For the range, that was a word. Actually, let me write these words out rather than just D and G. Range is the possible outputs, and if I smushed everything to the y-axis, notice these 2 points would get mapped there. These 2 points would get mapped here. This point would get mapped onto itself. And the possible outputs... Yep, and I'm going to write it from least to greatest, but I wouldn't mark it wrong if you wrote it the other order. Yeah, so perfect. That's the range, the possible outputs. Now, how about this one? I like this one a lot. This is like, I want to take my bike off of this. I want to play that app where you're like driving the truck and hitting ramps. Well, let me catch everyone else up first. I think you're right. Let's smoosh this down. Oh, and I did this one on the video? I hope I did this, well, maybe not, but I think I'm doing this one even better now. This one has better audio. Listen to my crisp voice. It sounds amazing on this microphone compared to last year's video. Man. So if I smushed this down, notice I would get a whole bunch of points, and I would even get like half points and fractional and decimal points, and everything would get smushed down between these two values, right? That the possible inputs would be, you could say, everything between -4 and 2. So the domain is going to be the set of all x, and it's more than just a short list. There's infinitely many things. So I say the set of all x, this vertical line like an absolute value bar, means such that, and x is between -4 and 2, and that's what I think Pooja was telling us, that it's -4 is less than or equal to x is less than or equal to 2. Excellent, excellent. Now, I really, really like this problem for its range. I like this a lot. Yeah, I said the same thing. Am I that predictable? Now, if you just were to base it off of the endpoints, is the range from 3 to 6? Does that describe the range? This is why I don't want to base it just off of the endpoints of my little graph, right? Because notice there are some values that are less than that. Right? I have a value right here. I have a value right here or over here, right? That would get mapped to values less than 3. and the lowest point on my graph, or sorry, yeah, less than 3, the lowest point on my graph is 2. So it looks as though this is between 2 and 6. Would you guys agree with that, right? The lowest point is 2. The lowest point is not this point, right? I think you agree. And so the range is going to be the set of all y, okay? That's usually where I make my mistake, such that y is between 2 and 6. So you know what I'm going to do? I'm going to write y between the numbers 2 and 6, and then I'm going to put less than or equal to signs in between them. All right, so there's my range. Let's see, I think I'm going to skip to the last problem for sake of time, because we've got a half day. I'm actually skipping to this one. Yeah. So, let's try this one together. I assume that we might have had some challenge on this, and I actually assume that some previous problems we would have as well. I might be able to look at those during an ACE block or something with you guys. It says the following. The graph represents the height h of a projectile after t seconds. Okay, so it looks like we're launching some object from 4 feet high, and over time, right, 1 second after it's launched, it looks like it's, I don't know, like 28 feet high or something like that. 2 seconds after it launches, it looks like it's 20 feet high here. And let me ask you this question. When does this land? How long does it take the object to land? Looks like, yeah, 2.6-ish seconds or something like that, right? It lands when its height is 0, and there's only this point when the height is 0. So that's a whole bunch of side information, but it asks the question, why is h a function of t? And I would say because there is at most one output for every input, all right? There is at most, I'll use their language, one height for every, man, with the spelling, for every time, right? So my height is my output, and my times are my inputs. Right? And it would pass what we call the vertical line test. Okay, and I was jumping the gun. Let's look at B. It says, approximate the height of the projectile after 0.5 second. That's so weird that I feel like I would want to pluralize that, but I guess it's less than one whole second. And so watch this. If I want to figure out how tall it is, I find 0.5 in seconds, and I'm going to go up to this point on the graph, and I'm going to read that over to the height. So it looks like the point at 1.5 seconds, it is 20 feet high. I could write that as an ordered pair. And if I wanted to figure out 1.25 seconds, 1.25 isn't on the number line here. Where could I find it? Where's 1.25? I don't have that numbered. Yeah, it's going to be halfway between those. Exactly. So here's 1.25, and if I read that all the way up, that looks like that's the highest the object ends up getting. By the way, that's going to be called a vertex when you're in... No, actually, later this course, we get to graph these shapes. Yeah, that's going to be great. So let's see. H, I don't know, I'm going to call that 28. Yeah, somewhere around there. I would accept either of those. And, oh, I called this 1.5. This was 0.5, wasn't it? That's sad. So 1.25 seconds, it looks like it's around 28 feet. Right? And they said approximate, so that's what we're getting. All right, now it asks this question. Approximate the domain of the function. What is domain? We got a lot of vocabulary yesterday. Right, domain are the x values, the possible inputs. And if I was to smush this down and smush this down and smush this down, it looks like the possible x values are everything between, let's see, the domain is everything between 0 and 2.5, or 2.6 we'll call it. Question. Does 0.9 seconds, is that a possible input for this? Yeah, 0.9. Yeah, right? Or how about like 0.8 or 0.7 or right? This object doesn't like somehow stop existing when it doesn't happen to be like a whole number of seconds or a half number of seconds. It exists all infinitely many points in between those values, right? So it's not a discrete graph, it's continually existing. It's continually in motion here. So I'm going to use set notation and say that domain is the set of all, actually, you know what? Let's call this t for time instead of x, right? Let's use their language such that what is t between? T is between the number, that's a t with a tail on it because I don't want it to look like a plus sign is my only reason. T is between 0 and we'll call that 2.6. And I'll use less than or equal to signs. And that 2.6 is an estimate there. So that's part C. Now they end up asking a question in part D that I think is really interesting that flips this on its head. It asks the question, is time a function of h? Let me actually try this trickaroo here. I'm not going to be able to mirror this, am I? No, I don't think I can. If I was to flip this, like so, let's say. And let's see, can I do... No. No, it won't let me do it. Well, anyways, if this was mirrored, okay, would this pass the vertical line test? Well, check this out. It hits multiple points, right? There are multiple times when it happened to be 5 feet high. And so time is not a function of h, but h was a function of time. So the answer is no. There are multiple times when the object was, let's say, I'll just say 15 feet high. There. So anyways, so that's an interesting way to set it up. But thanks for watching, Internet friends. Have a great day. Bye-bye.